Alright, you guys. So for the 15th day, we have to solve some sort of intervals problem again. This time we reach a cave system and it's not mapped, so we have to try and see where each tunnel goes to try to find the elves that sent the distress signal. So we have these drones, I guess, which have sensors and they can move around the cave system, and they will try to find the closest beacon, and I guess the beacons are signal sources. So the idea is that each sensor will connect with the closest beacon. So if we have a look at the map, we'll have these sensors marked with S, and I guess that each beacon can be connected to multiple sensors at a time. So so basically in the input, each sensor will connect to a beacon, but the beacon can repeat itself. So the range of a sensor spans using the Manhattan distance. So it goes one step in all directions until it finds a beacon, and then it stops because it locks to that beacon and it doesn't care about anything else in the distance. So for the first question, I guess to have something really simple, we had to see, for example, on a given row. In the example, they showed how to do it for the 10th row, but for the real input, we have to use the row 2 million. So the idea is that we want to see how many spots are covered by the sensor in that row, and we have to count all the hash symbols, and if there is a beacon, then that doesn't count because it's already, like, it's a beacon in that position. So we are interested only in all the spots where a beacon cannot be placed. Then I guess for the second part, this somehow made sense. What we had to do was to find the coverage of the entire map and find the spot that is not covered by any sensor. So that spot basically will be a beacon that we cannot see because we don't cover that spot. And I guess to make the input to the website simple, we have to multiply the coordinates with some numbers and return that. So for the solution, I used again this point structure, and yeah, I made some small helper functions like the Manhattan distance for this structure. It just adds together the difference between the x coordinates of 2 points and the y coordinates of 2 points, and it does the absolute value, and then it sums them. Then I have this line structure that will contain the source point and the beacon point, and also to not make the computation every time we keep the distance in this structure, the distance between the 2 points. Then I implemented the from string trait for the line, and pretty much we just have to split each line into tokens because they are separated by spaces, and then search for the numbers. So yeah, I guess it's a lot of error handling, but we first split by equal sign because each token is something like x equals to a number, so we want the right hand side, and we get it with dot 1. Then we have to remove the comma or the colon at the end of the token, and we can do that using split once. I guess we can use some slicing or something, and then we get the number, we parse it, and I guess it should work. Then we do the same for the sensor y position, then we skip some more tokens, then we get the beacon x position and the beacon y position. Then to parse the entire input, we just convert each line of the file into a line structure and keep everything into a vec of lines. Then I created some more helper functions, for example union, which takes two intervals as input, and if these two intervals are connected, either next to each other or overlapping, it will compute the larger interval that it forms. This is, I guess, connected to my idea of how to solve the problem, both for the first part and also second part. Then this solution function, which I used for both parts, basically it takes as input the lines, like the sensors, and I guess the sensors is the only thing that's important for the solution, and it also takes the y level for each for which we want to compute the intervals. So what we want to be able to do with this function is to get a row in the map, and using the sensors we want to find which spots are visible using that sensor, or using all the sensors in fact. So we have to filter all the sensors that are able to reach that Y level. So basically if the distance between the Y position of the sensor and the Y level is less than the Manhattan distance of the sensor, basically this is the maximum distance that the sensor is able to see because of the beacon. So we get all the sensors that are able to see that row. Then here I computed the interval on the x-axis that the sensor is able to see. So I call this variable spread because on the sensor level it looks in each direction with or a distance of this, but then as it gets further away from the sensor it gets smaller. So basically this spread is pretty much the redundant distance of the sensor, like it will use up some distance until it gets to this Y level, but then it will still have some more distance, probably at least one in the distance. So that will be how much on the x-axis it can go to the right and to the left, and using this spread we can compute the interval that it sees on the Y level for the x-axis. Then I use the sorted function to sort all the intervals by the first item in the tuple, and then I used my union function to group all the intervals in the smallest amount of intervals. So basically at first we have to add the first interval in the accumulator. Then if we can combine the current accumulator with our interval, then we combine it and we override the last element of the accumulator with the new larger interval. But if we cannot combine them, then we add the new interval as a new item in the accumulator. Basically we'll merge all the intervals into larger intervals, but we'll have a fewer number of intervals, so it will make the computations easier. Then for the first part I wanted to have all the beacons that are on the Y level, so I filter everything by the beacon Y position. Then I took the X position, and this is required so that we can remove from the answer all the beacons that are that take up the spaces of the sensors. Then we get the intervals using the solution function, and then we have to count all the positions that are visible using the sensors but are not already beacons. So then to get the answer we sum all these intervals together. Then for the second part, I'm not sure if this is the best way to do it because it takes like 10 seconds or something like that, but we have to iterate through all the rows. Then we get all the intervals for each row, and basically if the given row is entirely visible by the sensors, then we'll only have one interval from the beginning to the end. But if there are any gaps, it means that we will have more than one interval. So from the problem statement we know that there is only one spot in the input that we are interested in. So when we find the first occurrence, two or more intervals, we stop and take the column. And again, because we already know that there is only one element, then we take the first interval and add one to the end of the interval, and we do the computation from the requirements, like 4 million times the column plus row, and this will be the answer. And yeah, pretty much this was the 15th day. The second part was, I guess, a bit complicated. I tried to cheat it and search on the Reddit for a solution, but I couldn't find anything. I'm not sure how everyone solved it because they didn't post how they did it. So I tried a lot of things until I realized that probably we can use the first part to solve the second part somehow. So yeah, it worked it still took like 10 seconds, but it's not like other solution that took minutes or even more. And yeah, pretty much this was the 15th day. If you want to look at the code or do something with it, you can find it on GitHub, and see you guys next time. Bye bye.